So now let's discuss the objectives of the logistic regression. So the first objective of using the logistic regression is to identify the independent variable that makes an impact on the dependent variable, right? So we have the same relationship here, which was between the dependent variable and the independent variable, and the basic goal in logistic regression is to identify that what is the impact of the independent variable on the dependent variable. The second objective or the second goal of logistic regression is to establish classification system based on the logistic model for determining the group membership. Now, as I told you earlier, that there can be two types of logistic regression, right? So we have two types of regression, which is a linear regression and logistic regression, and the logistic regression can further have two types. So one is binary logistic regression and the other is multinomial logistic regression. So there is a very clear difference between these two types. The binary logistic regression is used when the dependent variable is dichotomous, right? And as you know, that dichotomous means that the dependent variables can have a binary output. That's why it is also known as binary logistic regression, because either it can output the probability of an outcome can either be 0 or 1. So it's a binary logistic regression case, because here we have the dependent variable is dichotomous. On the other hand, if we talk about the multinomial logistic regression, the multinomial logistic regression is used when the dependent or outcomes variable have more than two categories, right? So it is you can say that it is an opposite case of dichotomous, where we have more than two outcomes, or the dependent variable can result in more than two categories, right? So whenever you have two categories in your data set, so this thing basically depends upon the nature of the problem which you are solving through regression, or on the basis of your data set. If your data set or the problem is resulting in two categories, then your problem will fall under the binary logistic regression case, and you will need to use binary logistic regression in order to solve that problem. On the other hand, if your data set is resulting in more than two categories, for example 9, 10 or 11, or maybe more than that, then in that case it will be a case of multinomial logistic regression, and you will have to follow the multinomial logistic regression case in order to solve that problem. So here is a diagram which can help you understand that in linear regression, you know that we have a linear relationship between these two variables. So again, we are talking about an independent variable and a dependent variable, and the value of one variable is basically depending on the other variable. So if we have a unit change in one variable, then that change will also occur on the other variable as well. Now in the case of logistic regression, we can have multiple categories or multiple outcomes. So here we have only one output, but in this case our dependent variable can either be a dichotomous or maybe a multinomial. So logistic regression can fall in both these categories. Now let's discuss our regression equations based on the binary logistic regression and the multinomial logistic regression. So here is a case, or here is a regression expression which is representing a binary logistic regression expression, and you can see that this equation is very similar which we have seen before. We have a variable, outcome variable y here, which can result in a binary outcome, right? So here this variable y can have a category 0 or a category 1. So these are the two possible categories which it can fall, because it's a binary logistic regression case and we have our same coefficients here, right? So in this case, y is a dependent variable, right, which should be a dichotomous. b0 is a constant, b1 is the coefficient of variable x1, right? So again, with the change in x1, a change will be represented in beta 1, and x1 and x2 up to xk, these are all the independent variables on which our dependent variable is lying. And if you see this term e here, this is the error term, right? So you can also say that this is the term which represents that how much error are we having in the observed and the predicted variables. Okay, so now have a quick discussion upon the sample size, that how much would be the sample size and how does it affect our regression. So if we have a very small set of samples, then we have so much sampling errors, right? So this is a very straightforward thing, because in order to have a good regression equation, or in order to draw a good regression line, we need to have a reasonable amount of samples present in our data. So if there are very few samples in our data, then our regression equation will not be able to fit itself, and in that case we will end up in having so much sampling errors, right? On the other hand, if we have a large sample size, then it decreases the chances of errors, because it will have enough data or enough samples to best fit itself, and in that case the chance of errors will be low. So it's good to have large sample size in regression as compared to small sample sizes. Logistic requires large sample size than multiple regression. So as I told you, that if we have large sample size, then logistic regression will end up in less errors, otherwise we will have more sampling errors. So a sampling size of 400 is recommended in many studies. So sample size per category of the independent variable. The recommended sample size for each group is at least 10 observations per estimated parameters. So these are the minimum set of observations which we need to have in our logistic regression. So if we go below these observations, which is 10 observations, then we can end up with so much sampling errors. So the minimum amount of observations should be above 10 observations. So estimation of logistic regression model assessing overall fit. Logistic relationship described earlier in both estimating the logistic model and establishing the relationship between the dependent and independent variables. Result is a unique transformation of dependent variables which impacts not only the estimation process but also the resulting coefficients of independent variables. So now let's see that how can we assess the outcome of our logistic regression. So in order to assess the outcome of logistic regression, we basically use a common estimate which is known as a maximum likelihood estimation, and it is also represented as MLE. So MLE is a statistical method to estimate the coefficients of a model. So if we want to estimate coefficients of our model, we can use maximum likelihood estimation. The likelihood function, which is represented by L here, it measures the probability of observing the particular set of dependent variable values p1, p2 up to pn, which are occurring in the samples, right? So the maximum likelihood function L, it is basically measuring the probability of observing a particular set, and that particular set is represented by p1, p2 up to pn. And if we represent it with a mathematical equation, we can write it as L is equals to probability of all these dependent variable values. So if the result of this likelihood function is high, then the higher the value of L, it represents the higher the probability of observing the p's in the sample, right? And if we have low values of L, then it will have a lower probability of observing p's in the sample.